Good morning, or whatever time of day it is for you. So I wanted to give yet more explanation of what I'm expecting from grad and undergrad students as far as your final project, presentation, and so forth. So I've created these materials to show you and to also help you with the workflow if some people are still trying to figure out how to get this thing underway. So yesterday I decided to make up a pretend project. Well, here are the notes I wrote to myself. I typed them all up to show you the kind of things that I would write down for myself as I'm trying to figure this out. So for example, I found my data. I'll just show you where I found the data. So I've been really enjoying this data set here, but I wanted to leave all those available to you. So I decided I'd try a different source of data, and I looked through all these and I thought, 538, is 538 in here? Yeah, I have never tried data from 538, and I love 538. And so I decided that a lot of them were very political. I didn't want a political one. And I kept going until I got to the data set that I picked. And it happens to be the 2018 NCAA data set. Okay, and so that's what that link tells me. So let me go back here. Alright, so I picked that data set, and whatever data set you pick, you have to give me the URL and you have to give me the data set, both, because sometimes things change online and I want to be absolutely sure I have your data just in case something goes wrong. Now in theory I should be able to just pull it off the web, but giving me a copy is a safety backup. Now if you happen to make some small adjustments, because some people are merging data sets, for example in this project I added a couple columns, then give me the adjusted data set and still give me the links to everywhere where you got data. But your adjustments should be minor. They should be reduced to either they should either be like getting rid of columns because maybe your data set is too huge and you wanted to make it more manageable, or you can merge some files, or you can just add a couple columns. So for example, in my project I added a column that just essentially combined two dates, so that it was a 1-0 flag to combine two dates. Things like that. Add a couple columns, couple logical columns, just to make your analysis a little simpler. Nothing too deep. Okay, so if you have adjusted data, that's the one you'd turn in. If you do not adjust your data, then you just turn in the original file. Okay, then what I did is I made copies. I printed out copies of each of the relevant homeworks because I picked Stata and R and Pandas. And so I made myself an annotated copy. So I'll show you what I did in just a second. Hold on. This is my notes to myself. And as I was writing them, I wrote down exactly what I wanted. And so I made a list for myself. It's like a homework list. I wrote down everything I wanted to see and what variables they were coming from. And in fact, in my case, and you're welcome to do this if it helps you, I actually did a draft using StatCrunch, and it turned out that everything I wanted to do I could get out of StatCrunch. These particular things here, they are screenshots from StatCrunch, and that would be permitted. You can use StatCrunch just to display data, because StatCrunch is at this point only serving the role of a spreadsheet. So it's the same thing. You could take a screenshot of a spreadsheet, and so this is serving the same role. And so I just took screenshots right off of the browser to give some explanation of the data. And my very first draft, I just dumped in StatCrunch printouts so I could get an idea of how everything would look. And if you see my draft and then my final copy, here's my write-up, it looks almost the same. I just sort of changed the heading so it was prettier. I set things off in bold. I actually gave a proper title to my presentation, but most of the guts are the same. And then when I got to all the graphics from StatCrunch, I just swapped this out and said, okay, I'm just going to swap this out for graphics. I'm going to use proper graphics from. I decided to use R for nearly everything. So what I did is I knit to HTML. So first I took my R file and then I did the spin trick and knit to HTML, and so I got all these graphics to spit out automatically. I think we had the same trick in SAS. Like when you send something to HTML, it creates a folder full of pictures for you. And this one I had to hack. This one I had to generate separately because sometimes R just is difficult. Like it wasn't giving me all the names under my bars because it was compressing the graph to make it look right on the screen, which is kind of annoying. So I had to struggle with that a little bit. But I got all the graphics to work, and you can go ahead and read that the article I wrote if you want to see the level of detail I'm looking for in the write-up. But what I had done is after I did my draft, I went through and printed all these things out. And I told myself where everything was. I said, well, the first thing I want to do is summary. And so I said, how do I do a summary? There it is. And I put a 1 there because in my list of requirements for myself, summary was number 1. And 2 was my pie. And 3 was whatever it is. So I put little notes on the actual printout to tell me where I had instructions for everything. And I did that, and it's slightly different for each of these sheets. And that way I could easily find what I was looking for. Again, I did this for each of them. You can look through yourself. But the point is I want you to know that these are resources for you. You can make copies of the homeworks and mark them up, and that should make your life easier. So for each language, each script, each time I was writing a script, I was looking at one of these files that I had marked up, and I was looking at this little page I printed up. I printed up just this page so I could grab this checklist. So I was looking at the checklist. I was looking at actually at my draft. So I had I had 3 documents with me. Every time I was making another script, I had my draft and my marked up homework and my notes to myself where I listed my requirements, and that made it much faster to go look. Okay, so this is what my script looks like for my first language. It's not bad. Okay. The second language, I guess, is Python. I put them in some arbitrary order. It doesn't matter. Comment I wanted to make about the Python. The only reason I didn't call it .py is that GoDaddy is my hosting company. I don't host DonnaDietz.com at my house. I host it through GoDaddy. And when I tried putting up the Py file, and if you clicked on it, it would give you an error message. So I said, I don't care. My students can understand this. Okay, fine. I'm just going to call it txt. But on my computer, this file is a .py file. Okay? So that's it. Alright, now I will give you the presentation. This is roughly what I would expect a presentation to be. I think I will download that. Hopefully this is fine. Okay, so if I'm a graduate student, I'm going to do a 5 to 10 minute presentation on my findings from my data set. I start by saying, okay, I know nothing about basketball, but now I know a little bit about basketball. I found my data set at 538. It's a publicly available data set, and it contains 1,456 lines of data plus a header line. And honestly, it took me quite a long time to figure out how the data was organized, because there were 68 men's teams and 12 observation lines per team, and 64 women's teams and 10 observation lines per women's team. And so that adds up to 1456 plus a header line. And I could not figure out what was going on because 1456 is not really divisible by anything. So I was really confused. So it took me a while to dig through that. If you know anything about NCAA, here is what happens. We have, this is the chart for, I believe, just the men's teams. There should be, I think, 32 teams listed on this side and 32 teams listed on this side, and additional 4 teams listed in here. Maybe that's the way it goes. Let's see. I can't really read this because it's so tiny, but you've seen these charts before. And so as the teams play off each other, you figure out who wins, and Big Shock Villanova won in 2018. Okay, so there are something called play-in games. It's for the men's teams only, and this is called the first 4. They're called the play-in games because it allows them to play in the games. But ironically, they are games, but they don't really count as much because these games are played in order to get into the main grid. Alright, so there are, for each seed, normally you have 4 teams ranked at each seed, and I don't know if you can see it in here, what the seed values are. So for example, I think Xavier, Virginia, and I guess Villanova and Kansas, there should be 4 ranked at level 1. And there should be 4 ranked at level 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But there should be 6 teams that are ranked 11 and 6 teams ranked 16. But that means that we have to have some playoffs to let those teams in. So 2 of the teams that are ranked 11 are safe, and 2 of the teams that are ranked 16 are safe. But the other 4 in each category have to play off against each other in order to get into the main tournaments. Okay? Alright, if I look at my data set, I want to show you what my data set looks like. And I want to first show you all the predictions for Villanova and all the predictions for Michigan, and you'll notice what's happening. So the forecast dates are listed here, so they're going up in time. So this is the first beginning of March Madness, and this is towards the end of March Madness. And what this is this data that's being put out by 538, and each line of data has something to do with predictions as to how far Villanova will get. So right from the get-go, they predicted an 18% chance that Villanova would win overall. And Villanova is the team that ended up winning. So what they did is they said, okay, if the team didn't have to play in the playoff, this flag is set as 0. That means did not play in the play-ins. And so RD1, every team that did not play in the play-ins automatically gets claimed a win in that category. And so then round 2 is really round 1. So it's kind of named funny. Okay, so what they said is basically Villanova is going to win. Villanova won. So you see this step here, right here, this step means Villanova won their first game. And the reason why everything stays the same, there's just one large step, is that they're not playing in the games the next night. They only played in the games apparently the first night or the second. I guess it doesn't matter, but in the first round there were 2 sets of games in the first round. They only had to play. Once they played, or maybe there's 4 in the first. Anyway, the point is this thing changes after they win a game. Okay? And so you can see these steps look different for each team, and they're based on the dates in which they play. But a step means a win. So Villanova won 1, 2, 3, 4, 5. And then the data stop. So the very last round of games, the very final playoff between Villanova and Michigan. Notice Michigan has a very similar structure. So because Michigan happens to be playing against Villanova, and we just know this from the internet, we don't know this from the data set, there's a 35.6% chance that Michigan's going to win that final game, and a 64.4% chance that Villanova is going to win that final game. Okay, who do you think won? Well, it was Villanova. So notice, up until this point, I haven't done any analysis. I'm just telling you what's in the data and where I got it and what it's trying to accomplish. Purdue won 2 games, so you can see Purdue was not forced to play in the play-ins. So this 1-step, 2-step, 3-step. So it claims that Purdue won 3 games, but the play-ins don't count. So like 1, 2. Actually, only 2. So Purdue won here and here. So like 2 little bump-ins. St. Bonaventure did have to play the play-in and won the play-in, but did not go further. So you see the column up here is all zeros, meaning Purdue did not play in the play-ins. St. Bonaventure did play in the play-ins and did win, but then didn't win anything further. UCLA had to play in the play-ins, but did not even get that far. So you can see the prediction for this play-in team, UCLA, was only like 0.0008 for probability of winning overall. Okay, so I would ask, now finally starting some of the analysis, are the rankings relevant? Are they just completely random, or do the rankings actually feed into the seeds? I mean, actually they do it intentionally, so I will be shocked if this was anything other than correlated. I did not draw a best fit line. I didn't see it necessary, but I just wanted to show that this is kind of an S-shaped curve. The bulk of the data looks like it falls along a line, but there's basically some tails. The women's teams are spread out more than the men's teams. The men's teams are more concentrated along whatever their line of best fit is. The women's line of best fit would be tilted. But again, I didn't want to gum up the picture with the line because I wanted to look at what the data scatter plot with my own eyes. Another scatter plot I gave is I wanted to know how the play-in teams fared. So if you look at the rankings in this direction, and then on the other side I'm asking games won, then you can see, so what games win mean is for the play-in teams, they get no credit for winning anything if they don't get past the play-ins. And then the teams in red who are in games 1 equals 1, those red ones actually did win a game. They actually won a game to get into the playoffs. But the black dots indicate teams who were not forced to play in the play-in. So these guys actually didn't win any games at all. All these guys didn't win any games, even though they're in the column that says games won is 1. You see, so it's like they get free credit. So none of these guys won anything except for these 3 red dots. Now this one dot, this one team, did a really good job because they had to start at the play-ins and they actually got past the first level, second level, and they won that far. Okay, that's pretty cool. Up here are just actually Villanova is this dot and Michigan is this dot, and so there should be another level for Villanova, but they're not going to put out predictions after the last game is played. Okay, it turns out the region doesn't matter. How many games you won, and actually that's intentional. That's perfectly well balanced at the beginning because of the way they do the seeding. They want it to be balanced by region. Now actually this is kind of misleading. I commingled the men's and women's teams. So the men's are East, South, Midwest, South, and West. Those are the men's teams, and South did not have any play-in teams. So that's why it looks a lot like the women's bar graphs because, box plots, because the women's teams also did not have to play any play-ins. So that's why they have these, the men's teams have these weird looking box plots, because everybody's concentrated at one, because half the data reflects that nobody got past this point, right? So that's half the data. So this is the for the men with the play-ins, there's a single team down here at 0, but most of your data are concentrated here. For women, if this is the first, like 50% of the data is actually just concentrated at 1. It's just that the bar graph, the box plot just kind of looks funny. Okay, so I learned about NCAA March Madness. Chi-Square told me what I could have Googled, and I didn't even bother putting a slide, that each region gets seeds 1 through 16, and that's why everything is so perfectly balanced by region. And then I felt kind of silly for chi-squaring something I could have Googled. But anyway, I demonstrated that in my write-up. And so the seed values are not regionally biased because they're manually manipulated, and there are slight differences between the men and women's ratings. I found out that the ratings are pretty good at predicting which teams will move ahead, but sometimes they're wrong, and that's why it's fun. Okay, and that's just the overview of what I did for my work. Okay, and so that would be a nice presentation because you're just kind of giving an overview. Again, there's going to be a lot more data in the write-up, a lot more information in the write-up. It's going to actually give all the gory details. It's going to tell actually how you manipulated your data file, if you did, which variable names. So for example, in my write-up I explain every variable that I use, and I use basically all my data. But if there's columns that you are not using and they're not relevant, then you don't have to explain them. But you have to explain all the columns that you're using, and any columns that you create. Okay? And what else? I think that's the point. The point is your talk should be short and sweet and just give the high overview and not necessarily give every single chart or graph that you created, but just you're explaining it to somebody. And the write-up is you're explaining to me every single thing that you did. Alright, I'm hoping that this will help you understand what you need to turn in. Again, these are all things I suggest you make for yourself, and down here are all the things I want to see and flagged by grad students only. So the grad students don't need the second or third script. I'm sorry, the grad students only need the second or third scripting language and the presentation slides.